Hi everyone. So we're going to talk about conditional probability today. We introduced it on Friday and talked about what words we can see that would let us know that we're talking about a conditional probability that's putting a constraint on our sample space. We talked about the more obvious words like given and if, and then we also talked about the words that are a little bit more difficult to notice, which is also and who. And we came across one or two problems where it was a conditional probability that didn't use any of these, so that's possible too. Okay, these are definitely your most common and the easiest trigger words to notice that we're talking about a conditional probability. Okay, just remember with a conditional probability, it typically puts a constraint on our sample space and is putting a condition on it, so our sample space gets smaller. Okay. So we'll start off with 6 problems where we just talk about some simple probability with dice and cards and gender, or dice and cards, and I think that's about it. Okay, so this one says, Alexis rolls. If you guys have actually a highlighter, it would be useful to have a highlighter out. We can highlight some things that are stand out. It says Alexis rolls a pair of number cubes. Number cubes is just another name for dice. I'll write that in case you see that. So notice it's a pair, so a pair of dice, so 2 dice. What is the probability that both number cubes are odd if their sum is 6? So right here, this if their sum is 6 is what's important. Okay, that's what we want to focus on first because that's going to set our sample space. So if their sum is 6. So you guys have a dice sheet. You can look at your dice sheet. The sum of 6 really isn't that many, so I'm just going to actually write them off to the side. Sum of 6 would be a 1 and a 5, a 2 and a 4, a 3 and a 3, a 4 and a 2, and a 5 and a 1. So there's 5 of them. Okay, so that's my sample space, and since I have them written out, I can actually see them as well. So now I'm saying out of those 5, I go back and I reread, what is the probability that both number cubes are odd? So both odd, and both odd. So there are 3 out of 5. And that's simplified, so I'm good. And I'm going to leave it as a fraction. Whenever I have these types of problems, leave it as a simplified fraction. Okay? All right, the next one says, what is the probability that a red card is drawn if the card is a face card? So if the card is a face card. So that is my sample space. So if the card is a face card, there are 12 cards that are face cards. So I'm thinking Jack, Queen, King of each suit. Okay, I go back, it says, what is the probability that it is a red card? So out of the face cards, half of them are red cards. 6 are red, 6 are black. Okay, so then simplified, 1/2. All right. Okay, next problem. What is the probability that a card is less than 6 given it is black? Okay, so here's our sample space, given it is black. So if we think about our deck of cards, we have 52 cards, so 26 of them, half of them, are black. So what is the probability that a card is less than 6? Notice that I keep going back and rereading. Okay, less than 6. Well, less than 6 would mean that it is a 2, a 3, a 4, and a 5. Less than 6 cannot be 6, and you can't have a 1. Okay, so given that it is black, 2, 3, 4, 5. So there's the 2, 3, 4, 5 of clubs, and then there's also the 2, 3, 4, 5 of spades. So those as well. So 4 of each. So then that means that there are 8 out of 26, which simplifies to 4 out of 13. Okay, let's try another one. If you roll doubles, so notice this one, the condition was written right in the beginning. So if you roll doubles, what is the probability that the product is greater, so product is greater than 5? So rolling doubles, we're talking about dice. So if you roll doubles, so I'm going to write them out because that's my sample space. I know that there are 6 doubles. Doubles are talking about 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. Okay, so there's my doubles. Notice that this is what I care about first. I don't care about anything else. Okay, so those are my doubles. Now, out of those doubles, what is the probability that the product is greater than 5? So greater meaning 6 or more. Okay, so this is 1, this is 2, or sorry, this is 1, this is 4, this is 9, 16, 25, and 36. So 4 out of 6, which simplifies to 2/3. Okay? So conditional probability is actually pretty nice because now you're not looking at all those 36 outcomes. You're looking at a very smaller subset. All right, given doubles. So given doubles, again, I'm not going to rewrite them. I'm actually just going to go back up to this that I have. What is the probability that the, let's see, what is the probability that the sum of a pair of dice is odd? So we're looking at sum is odd. So we know that if it's talking about doubles, it's got to be 6 of them, these 6 that I just wrote, that the sum is odd. Okay, so 1 and 1 is 2, so that's not it. 2 plus 2 is 4. 3 plus 3 is 6. 4 plus 4 is 8. So I'm just going to write these off. So add, you get 2, you get 4, you get 6, you get 8, you get 10, you get 12. So out of those doubles, none of them have a sum that is odd. So that means there's 0 out of 6. So there's a 0% chance. Okay? Next one. What is the probability that a pair of dice is doubles if, so now the if's back at the end, if the sum of the dice is odd? Okay, so now I'm looking at if the sum of the dice is odd. There's a lot that have to do with this, so I'm actually going to go to my dice sheet. So I'm thinking if the sum is odd. Okay, so sum right here. So sum is odd here, 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 here. So I'm just going through highlighting all these because it should be like every other one. Then I'm going to go back and count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So notice it is half of what we have. Half of them are going to be an even sum. Half of them are going to be odd. Okay, if I go back, I'm going to reread this question. What is the probability that if the sum of the dice is odd? So I have 18, so I'm going to write that down. So 18 is my sample space. What is the probability that a pair of dice is doubles? So now when I look at this, I'm looking at everything I highlighted to see how many of them are doubles. Well, my doubles are 1 and 1, so that's not highlighted. 2 and 2, that's not highlighted. 3 and 3, that's not highlighted. 4 and 4 is not highlighted. 5 and 5 is not highlighted. And 6 and 6, that's highlighted. So that means that there are 0 of them. So just kind of like the last one. So out of the dice that have odd, none of them are even, which kind of makes sense because if you look back at the last 2 questions, we had 0 for those, or 0 for the last one. Okay, so 0. All right, so when you read those types of probability questions, make sure you always find your condition first, find your new sample space, and that sample space is what you care about. Okay, always focus on your sample space first. Okay. Oh my gosh. All right, the PGA, or Professional Golf Association, has younger golfers, less than 40, so younger than 40 years old, and older golfers, 40 or older. The statistician made the following notes. Y is going to be younger golfers, O is going to be older golfers, and W is wins or winners. Okay, go ahead and write this down. So this says the probability of A given B. Okay, remember this vertical line right here counts as your given. So probability of A and then a vertical line B we read this as the probability of A given B. Okay, the second part, this B, is your sample space. Okay, so take a minute and write all that down. Okay, and then once you've written that down, I just want to read through these. So this would be read, the probability of young given winners is 15%. This one would be written or read as the probability of winners given that they are young is 5%. The probability of older golfers given that they're winners is 85%. This one is read as the probability of winners given that they are older is 72%. Okay? So, given this table, okay, we have everything that was set up above. It says, what is this sample space? So notice if this is young given winners, the sample space is winners. That means we're looking at everyone who is a winner. Okay, meaning that they've won a tournament. Probability of winners given young. So this sample space is that they are young. So only 5% of the young golfers are winners. This one, the sample space is winners. So this one is talking about out of the winners, how many older golfers win, 85%. This one, the sample space is older golfers. And this one is saying that out of the older golfers, 72% of them win. This one should say younger golfers. Oops. Younger golfers. Okay, so let's see if we can understand what this is saying. If you pick a random golfer from the group of winners, is it more likely that you will pick a younger golfer or an older golfer? So notice there's a condition on this. If you pick a random golfer from the group of winners, well, here's a group of winners, and here's a group of winners. All of that is my sample space. Okay, so out of those winners, is it more likely that you will pick a younger golfer or an older golfer? Well, this one is younger 15, and this one is older 85, which should make sense because that tallies up to 100%. Okay, so that means that it is more likely that you pick an older golfer. So we're going to say it is more likely to choose an older golfer and I'm going to say 85% versus 15%. And then I'm going to say out of the winners. So it is more likely to choose an older golfer out of the winners, which should make sense because older golfers have been around longer. They have more of a chance or likelihood of winning because they've played more tournaments. Okay. The next one says, given that a golfer is older, okay, so here's our given. Given that a golfer is older, what statement can you make? So given that a golfer is older, which means then we are talking about this one right here. So this has the sample space that we're looking at. So given that a golfer is older, what statement can you make? Well, it says that out of the older golfers, 72% of them win. So that's what this is saying right here. Okay, so given an older golfer, what statement can you make? We can say that 72% of them are winners. So 72% of them have won a tournament. Okay, flip it over. Alright, so this problem's got a lot of words and a lot going on, but there's two things that we're going to look at. We're going to revisit independence, so R, Y, and W independent, and then we are going to find the probability of two conditional statements, and then we're going to interpret their results. Okay, so before we go through and read, since we're going to do this anyways, I'm going to write it out. So R, Y, and W independent. Remember, in order to determine independence, we want to know if the probability of Y and W equals the probability of y times the probability of w. Okay, so that's my checking for independence. Alright, now let's go through and read. It says, a vacation resort offers bicycles and personal watercrafts for rent. So, bicycles and personal watercrafts. The resort's manager made the following notes about rentals. 200 customers rented items in all. So this we can say is our sample space. Um, 100 rented bicycles and 100 rented personal watercrafts. So half in it. Okay. Of the personal watercrafts, so that's a conditional statement. We're looking only at the personal watercrafts. 75 customers were young, 30 years old or younger, and 25 were older. Also, 125 out of the 200 customers were age 30 or younger, and 50 of these customers rented bicycles, and 75 of them rented personal watercrafts. Okay, so here's what I know. These are my events. Y is that the customer is young, so Y is young, and W is a watercraft. Okay, I want to determine these three things. So I'm going to go and find the young and watercraft. Okay, so young and, so that somebody was young and they rented a personal watercraft. Well, it says that there were 200 customers rented items in all. So I know that that's my sample space. So there are 200. And I want to know, out of those 200, how many were young and rented a personal watercraft. Alright, so let's see. Of the personal watercrafts, so notice this this statement right here says of the personal watercrafts. So that means I'm only looking at personal watercrafts. 75 of the customers were young. So notice that's actually hitting both the things that I need. That's watercraft and young. So I'm looking only at these, and 75 of them were young. So that means both of those. So that is my young and watercraft. So 75 out of 200. Now I need to look back and look for how many people were young. Let's see. My third bullet point says 125 of the 200 customers were age 30 or younger. So 125 out of 200. Now I'm looking for how many people rented a watercraft. If I go back up to the very first one, it says there were 200 customers, 100 rented bicycles, and 100 rented watercrafts. So that would be 100 out of 200. So 100 out of 200. Okay. Right, using your calculator, 75 over 200 is, I'm going to change these into percents because remember, anything within 1%. So this is 37.5% equals, and if I multiply these two together in your calculator, make sure that you put parentheses around them, you are going to get 31.25%. Okay, those are not within 1%. Those are almost 6%. Well, a little bit more than 6% apart, so they are not equal. If they are not equal, that means that they are dependent events. Dependent events. Okay, make sure you state what they are. And your quiz, some of you guys just went right into your sentence and never actually stated, are they independent or not? Okay, so they are dependent events. And then we're going to write a sentence about it and talk about what it means. So this is where a lot of us struggle too with understanding how to write this sentence. Dependent means that that it does depend on the other, but when you are defining it, you don't want to use the word depends. You can't use the word to describe the word. Okay? So I'm going to say, I'm gonna use the word affect instead of some of you guys trying to use the word depend. So I'm gonna say picking. Notice I'm talking about young and watercraft. So picking, and I'm just gonna go with young since that's what's written first. Picking a young person does, that's the important word, affect the chance that they rent a personal watercraft. Okay, so dependent mean that it does affect. Okay, and that's really all you guys need to say is that something does or does not affect the chance. Okay, so picking a young person does affect the chance that they rent a personal watercraft. So now let's go down to the next one where we talk about conditional probability. We're going to find the probability of each of these. So we're going to find the probability of young given watercraft and the probability of watercraft given young. So I'm going to first say, okay, I'm going to look how many people are in watercraft. So if I go up, I can see that, again, there are 100 renters who rented personal watercrafts. So that's my sample space. There are 100 watercrafters. Out of those watercrafters, I want to know how many of them are young. And then actually the third bullet point says 125 of the 200 customers. Sorry, that's not it. I'm looking only at the personal watercrafters. And then notice it says in the second bullet point, of the personal watercraft customers, 75 of them were young. So that means of the 100, 75 of them were young. So that's my first fraction down here. 75 out of 100 were young. Okay, and that is 75%. Okay, and then over here, I'm looking at how many were young. So that's my sample space. 125 of the 200 customers were age 30 or younger. So 125 were considered young. And now I'm saying out of those 125, how many of them rented personal watercrafts? So if I go back up, 125 of the 200 customers, 125 of the 200 customers were age 30 or younger, so that means they're talking about my younger. And then notice it says 50 of these customers, so I'm talking about my young customers, rented bicycles, and 75 out of them rented personal watercrafts. So 75 out of 125. If I divide those, I get 60%. Okay, so that's the first thing, is just to find those probabilities. And then when I interpret the results, I'm always going to, just to make it easier on you guys, I'm always just going to talk about which one is more likely, which would be this one, 75%. Okay, and my statement, my sentence, just kind of like before, is going to say that. So, and I need to state what the conditions were. So I'm going to say, given a personal watercraft renter, right, because again, that's my sample space, it is more likely a young person will be chosen. So given a personal watercraft renter, because that is my sample space right here, it is more likely a young person will be chosen, because that's what I'm looking at out of that sample space. Okay, so that's a lot of what your homework will be today. Your homework will start with the conditional probability, talking about dice, talking about cards. You have 6 of them, so go back to your notes if you need to. And then you have problems where we're going back and talking about independence. Okay, are these events independent? Remember your formula. If not, go back to your notes. Okay, when this says that Jack rolls a number cube 3 times, you're not talking about all 36 of your outcomes from dice. Notice it says that the roll is odd, which means that if you're talking about odd and even, then it just looks just like flipping a coin, because there's a 50% chance when you roll a dice that you get an odd or an even, because there's 1, 3, 5, 2, 4, 6. So you'd make up your outcomes, and you would say odd, 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 even, odd, even, odd, and odd, even, even, and then you do the same thing for even, 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 and that would give you 8 total outcomes, just like flipping a coin. Okay? And then 3 children, same thing. It's boy, girl, so you'll have the, 8 outcomes, but B and G instead. Okay, and then the back looks pretty similar to the back of the notes. Okay, you have 2 of those. All right, I will see all of you guys tomorrow. If you have any questions, come in and see me in the morning. Thank you.